All right, 6-4 day 2. We are still graphing away. All right, a couple new little things for us to try today, okay? Because if you remember to day 1, amplitude, we called this A, right? And this formula is more just kind of like intuitively what it is. We don't use it very often because, number one, we typically are given A, and we don't know the max or the min, but that's just illustrating what it is, okay? The other piece we looked at is the period is 2 pi. 2 pi over b. Okay? So again, looking back to the first day, that's what we covered here, by the way. We're not going to need those, okay? Because here's what I tell you for vertical translation. First thing, when you see in this general formula up above, that's D, okay? A couple things I want to tell you about it. That tells you how much the graph has been shifted up or down. The second thing is I want you to mark this first. It's kind of weird because you look through it in the equation and you're like, well, it comes last at the equation. It doesn't have to go last, right? You could move around the order of the terms, but that's not what you'll see today. But I want you, even though it's the last term, I want you to mark it first. Okay? I'll explain why when we get to an example. Okay, but that vertical shift, mark it first. Over here for the horizontal, this is going to shift it left or right. The question I want you to look at with this is, where does the first period start? Okay, find this point. Okay, find out where that point is. That's going to be really, really helpful because basically what's happening is if you got that horizontal shift, you might be finding that first period of your sine or cosine curve doesn't start at 0. Well, okay, let's figure out where it is, right? Because that's really, we kind of get into all of our details to figure out where the first period is. Once we have one, then we just kind of copy it, a second one, okay? All right, from here, let's dive into some examples. 3 sine x plus 2, okay? Instructions here is let's graph 2 full periods of this curve. Okay? Now, if we were to make an accurate graph, which is what we're after here, we typically, with other types of graphs, we'd make a table of values. Or we'd kind of use some tricks that we knew about that particular function, right? With quadratic, sometimes we did some fancy stuff to mark like x-intercepts and whatnot, but that was kind of our default, was to make a table of solution points. Trig functions, we typically never do that. Okay, we create what I like to call the function's profile, okay? It's usually at most like 4 characteristics that are going to help us graph it, okay? For your profile, I would say right off the bat, I'm paying attention that the amplitude is 3, okay? It also has D, the vertical shift, up. Now, even if period is unchanged, in this case it is, I always mark it. It's very important before I make the graph that I know what the period length is. Standard for a sine curve is 2 pi, unless it's been changed, right? There's nothing in front of x up here, so it's unchanged. All right, now you're going to see the graphs today. I'm not going to graph the original sine curve first. A lot of answer keys, you'll see that. If it helps you do it, nothing wrong with it at all. You don't need to, okay? If you don't want to, you don't need to. When I said on the other slide to mark the vertical shift first, here's what I meant. Right here at 2. Okay, I'm going to build the rest of this curve off of that. Okay, build it off of 2. Because now when I get into the amplitude, I go up 3, right? But we're going to see, because there's the vertical shift, it's not like yesterday where it's like, oh, the amplitude is 3. This graph is going to go up to 3 and down to -3. Actually, no, it's not, okay? Because of the shift. It's going to go up 3 and down 3 from wherever the shift was. So now when I go to mark it, it's up to 5, and it's down to -1, okay? But if you mark where, like that horizontal dashed line I put in as to where the vertical shift is, you just kind of build off of that, which is why I was saying mark it first. Okay. All right, so here's my sine curve. It'll start there. There's 2 pi, there's 4 pi. Kind of work on the first cycle here. It'll hit its max, and then hit its min. And cycle number 1 is going to look like this. There we go. And up to 5, down to -1, and back to 2, okay? Nothing new with the amplitude, but there's the first one you've seen that's got the vertical shift. All right, let's take a peek at this one. It's got 3 things going on, 3 things. Now, you're going to see this is just really because of space. I'd love to see you do 2, but I kind of looked this one over. We'll just do 1 period for this one because the period is going to be kind of long and stretched out. And there's really not a good way with the room we have to do 2. All right, let's start with our profile. A is a half, okay? Kind of means vertically, as opposed to the last one where the graph kind of got stretched out. This one's going to kind of get squashed. I'll move on to period. That is 2 pi over b. B is pi over 4. So this one is definitely changed. We saw yesterday if our value for b has pi in it, it means that our period is getting changed to something that is not in terms of pi, like 8. And then we do have a vertical shift to go 3 units down. So those are the 3 things that I notice are really relevant to this particular graph that I wanted to mark. Okay, the first of which I always go on the graph is, right, this. Mark that first. Because then we're just able to build off of -3, okay? Now I go to mark the period. No horizontal shift. We haven't seen that yet, so period number 1 is going to start at 0. And it's going to end here. And you see that the first period takes up most of the room that I have, which is why in this one we're going to say we'll just draw 1. Okay? You draw 2 unless you're told otherwise. But here you're told otherwise. Okay, so a cosine curve starts at the max. Okay, this one's a little bit tricky to see here. In fact, I might zoom in a little. Whoops. Oh boy, that's not good. Can't zoom in. My writing didn't move with me. Well, we'll just have to leave it put. Cosine starts up at the top, right? Which here, it's not going to be very high and very low, right? That's negative 2.5. And then by 8, we need to be back at negative 2.5. At 4, it drops down to negative 3.5. Then I cut those in half, and I'll hit negative 3 right there. It's negative 2.5 down to negative 3.5, back to negative 2.5. Okay? Just to be clear, the reason I was going up and down a half, that's because of this, right? I can use that, right, the plus or minus half, if I'm building off of where it's centered, which is down 3 units, okay? We can kind of treat amplitude like yesterday if we mark that vertical shift first, okay? So really the only thing that one had is it similar to the first one, but it included a period change. Okay, let's make a profile. A is 2. Nothing for B. Okay. Period's 2 pi. You don't have to mark this, but just so we're clear, that period is unchanged. C is pi over 2 to the right. That's obviously the new element this one's going to bring, is it's got a horizontal shift. D is 0. Don't need to mark it. Okay? And I always pay attention to this because it can be sneaky. Got that negative sign out front. That's not really anything new or that's like unique to trig functions. We've seen those with like every function family we've studied. That negative sign up front is a reflection over the x-axis. So, okay. This one's got a lot. I mean, technically the most, if you're going through the items in your profile, would be 5, right? If you had A, B, C, and D, something going on for all of them. I didn't address D here. Like if you thought it was simple to say, hey, I'm going to go through, I'm going to address all 5 things every time. Not a bad way to do it. Okay, if you know one just isn't there, like this one doesn't have a vertical shift in your profile, I would say just don't address it, right? Vertical shift is 0. So if you had something going on for all 4 and a reflection, you theoretically could have a profile that has 5 items. We haven't seen that yet, okay? It's about as fancy a one as we could do. Now, I said the very, very first thing you got to do, right? Mark your vertical shift. This doesn't have one, right? It kind of already is, right? You've got your x-axis right here. It's just, I'm going to be building off of that, right? Because next I go to amplitude. This is one like yesterday with that amplitude. I'm just going between 2 and negative 2, right? No vertical shift. Okay, time to get into pi, okay? Pi over 2, rather. Our vertical shift. Right here, I'm going to mark it. This is where the first period's going to start. Normally, we're used to it starting at 0, but it's bumped pi over 2 to the right, okay? Here's 2 pi. That's where it would finish. That's getting bumped over 2, okay? It's kind of like everything is getting bumped pi over 2 units to the right. All right, so from here, I'd hit my max at 2. Go back to 0, down to negative 2. And there is 1 period of my sine curve. Okay, shifted pi over 2 to the right. Now, if I go over the opposite way, because there's not enough room to do 1 to the right, 1, 2, 3, I could think of this one as my second. Go here, here. So when you do 2, you can typically you could do your second to the left of your first or to the right. It doesn't really matter, right? But notice how there I kind of counted the number of squares that I had on my x-axis. Because again, after you make that first, right, I'm like, okay, here's pi over 2. That's where I need to start. And then I went 1, 2, 3, 4 to see from 2 pi, right? Because that's an easier number to reference because you know if things haven't changed horizontally, stretches or shifts, the first period of a sine curve should end at 2 pi. So that one got bumped too, right? So then I'm looking down here, right? And I counted those off and basically saw 1, 2, 3, 4 units, right? So then once you have that reference, it's like, all right, I need to go 4 more on either side, and that's gonna be my next period, okay? By the way, I should have told you at the beginning, that's one we were gonna do 2 periods. Last one will be the same. Again, that's kind of our norm. But again, to summarize on that one, really the only kind of new piece you got going on, that one had your horizontal shift. Here is our last one that will also have a horizontal shift. Let's make a profile. A is always a breeze, right? You can find it right away. Notice when I'm addressing A, right? I just call it 3. I see the negative sign. If you wanted to take that, and maybe this would be a better order, because you kind of tend to see the negative sign right when you see A. I didn't address it till the end, but you could go right over here as well. Reflected over x-axis. Right? Reflected over x-axis. Then I get into B, which really B is 2 pi, like 2 pi over B to address the period. 2 pi, unchanged. Okay. Whoops, we don't need to say units there. I do want you to specify when you say pi. This is going pi units to the left. D1 up. Right, so here you actually see what I would call a full profile because I've addressed 5 things. Now technically, right, it's not the case I was talking about on the other slide where it's like, oh, it's got the most going on. Because the period wasn't changed. In my profile, I referenced it because I always like to, because it's super important to know, oh, how long is the period for this sine or cosine curve? So notice on all of them I've talked about period. But that's still 2 pi. B is just 1 and it hasn't changed. Other than that, 4 things going on. Amplitude has been stretched out by 3. You do have a reflection. Shifted pi to the left, shifted up 1. Okay, it's kind of the most going on that we've seen in terms of kind of shifting and stretching this cosine curve. Now, with all that going on, great little question to kind of quiz yourself is to see how you're doing. What should we start with? Okay, address it in the very first page. What should we start with? Your vertical shift, right? Always start with that because it gives you like this framework to build off of. It's been shifted up 1, so I like to go and mark with a horizontal line, and it's almost like from there, I'm going to pretend that's my x-axis because my whole graph is going to be built off of that dashed line, okay? Which is why I love marking it first. Now I get into amplitude. If I go up 3, I got to get up to 4. I got to get down to -2, so I got that, okay? Next piece gets back to C. where does the first period start, okay? With a cosine curve, it would typically be 0. We need to go pi units to the left. So I go back over here, and I'm just going to kind of circle it because there's some other stuff I got to figure out, but I know it's going to be right there, okay? We're at negative pi, right? That's where it's going to happen, okay? Now, the period hasn't changed, so the other thing I'm going to go ahead and mark is I'm going to go over here to pi. That's where the first one's going to end, okay? Still has a length of 2 pi, right? That's what I'm really looking at is once I figured out where I'm starting, just add 2 pi because the length here is still the same, and that's where you've got to finish, okay? Now, the last piece is where I'm going to start, right? Cosine typically starts at the top. It's been reflected. Okay, so I'm over here at pi. I have to start way down here at negative 2. Okay? Now, I usually like to jump to the end and go to pi and say, all right, that's the point. I need to be back down to negative 2. I should peak in between. And then from there, I should hit 1, okay? Okay, so I got 1, right? I can kind of do a half on the other one, right? Because I can do like another half a period. So I could mark on this one, you know, to get to 2 pi, that's just half a period. So I could go there. And then I could go back this way, get up to 4 again right there. And go like that. So I did whatever. I did 2 sort of, right? Just kind of built a half period on either side. Okay, that is a wrap for 6-4 day 2. And that's really between these 2 days for examples and kind of like seeing everything that we'll do with graphing trig functions, which again, for us just means sine and cosine. You've seen it.